Okay, so this is going to be our remake and our packet makeup for last week's quiz. I'm just going to go through the quiz that you took last week, problem by problem. And as I get through each slide and each page, I'm going to leave a couple additional practice problems up for you to complete real quick, and that's how you'll make up your work for last week. So let's dive right into it. Our first problem, it says, what is the equation of the line pictured? So we have to look at this line, and it had some hints in there. It says, that said rise and that said run, okay? So all you have to do is figure out A, where your y-intercept is, which in this case, it's right here, which is 1, 2, 3, 4 units up. So I know it's going to end with a plus 4, because in my equation, y equals mx plus b, this is my y-intercept, okay? So now I know I'm going to end with plus 4, then I just have to figure out how much rise I have. That's plus 4, and it's a plus because I'm going in an upward direction, and this would be 1, 2, 3, 4, 5 units, plus 5 because it's 5 units to the right. So it's always my rise over my run is my slope, or it's my change in y over change in x. So it would be, in this case, my change in y was plus 4 over plus 5x, and that's my equation. So y equals 4/5 x plus 4, and then I just look at which one it would be, which it has to be that one, so my solution to that question would have been A. It's not 5/4, that's backwards, that's negative, so it would be going in a downward direction, and that's negative, so it would be going in a downward direction. The next question is asking, what does the m represent in this equation? Well, the m represents my slope, okay, or we could call it my rise over my run, or my change in y over my change in x. Those would all be acceptable answers. If I look here, it's not my y coordinate, it's not my x coordinate, it's not my y-intercept, it's not a fraction all the time. It's always the slope of the line. So that is my slope. So that answer would be D. Again, we could say rise over blank to describe the slope of a line. Again, as you can see here, I've already answered that question, building off the previous one. It's rise over the run. So it's not east, it's not macaroni, it's not vertical, it's not the fall, it has to be run. So C would be my answer to that question. For this one, which of the following is another way to think of the concept of slope? Again, we're all the way back up here into my equation. We have slope is the rise over the run. It's the change in y over the change in x. So if I look, it's not a type of groove. It's not rise over the fall. It's not a translation of a shape. It's not the change in x over change in y. It's change in y over change in x. Again, just reinforcing the slope concept for you. So now I'm going to take a break as I go on to my next page. You're going to have some time to work on problems on your own. Okay, so as we hit page 2, now we're starting to look at more pictures of it. So it says, what type of slope is shown by the snow line in the picture? So it's looking for the snow line. And remember, when we're looking at slope, we can always just cover the left side of our graph and see which directions it's pointing. In this case, whoops, I'm going to go undo that. Okay, in this case, my slope is pointing in an upward direction, which means it has a positive slope groove. Okay, what type of slope is shown in this picture? Well, in this picture, it's going straight up and down, which from the song we do is called the undefined slope. So, B, undefined. Again, what type of slope is being shown in this picture? Well, I'm going to cover up my left side of the graph and see that it's pointing in a downward direction. If it's pointing in a downward direction, it's always a negative slope. Again, see, cover the left side up and you see it's pointing downward. What does the B represent in this equation? Well, if M was the slope, B is my y-intercept. Okay, so that tells me where it crosses the y-axis. So it's not the slope of the line, it's not the rise of the line, it's not the y-coordinate, it's the y-intercept. And what is the slope of the line whose equation is 3x plus 7y equals 21? Well, there's a couple ways you could have done this problem. You could have just solved for y. So we just said what's happening to y? Well, we're adding 3x, so we need to minus 3x, and we're timesing by 7, so we need to divide by 7. So you'd have minus 3x minus 3x. That goes away, so now I have 7y is equal to negative 3x plus 21. And I divide everything by 7. I'm left with y equals negative 3 over 7x, and 21 divided by 7 is 3. So that'd be the finishing pieces. Then I just need to know what one's my slope, which one's my y-intercept. Well, the slope's what's touching my x, so it'd be negative 3 over 7. So I cancel all these guys out and just be left with my answer there. So now that we're done with the second page, again, I'm going to give you guys some time to do some comparable problems on your own. Okay, so we're back. It says, what is the y-intercept of a line whose equation is 3x plus 7y equals 21? Well, I've already solved out my equation. Last time I did it by solving for y. This time, why don't I use my trick? I know that my standard form of the equation is ax plus by equals c. So my slope is always the opposite of a over b. So in this case, it would be the opposite of 3, which is negative 3, over b, which is 7. So I know that that's my slope, and then my y-intercept is always c divided by b, which in this case would be 21 divided by 7, which leaves me with 3. So my answer would be 3. All those would go away. Okay? Or you could have just solved for y, or you could have just looked at your previous work where you already had the equation in slope-intercept form and know that it was plus 3 to end on. Okay? Now we're getting into systems a little bit with this guy, and it's asking how many solutions are there to the systems of equations below. Well, from my notes, I'm looking at I have different slopes. And if you have different slopes, according to our notes, it means we have one solution. Okay, if I had the same slope and the same y-intercept, I would have infinite solutions. And if you had same slopes and different y-intercepts, you'd have infinite solutions. But since it's different slopes, it can't be no solution or infinite solutions. There's no such thing as undefined solutions, so it has to be one solution. Again, following the exact same thought process, how many solutions are there to these equations? This one's a little bit different because this is in standard form. So I need to solve for y to get it there. So I'm going to see what's happening to my y. I'm adding 3x, so I need to minus 3x. And that's it. Y is by itself after that. So now I'm just going to go 3x plus y is equal to 5. I'm going to minus 3x from both sides. And I'm left with y equals negative 3x plus 5. And I'm looking at my slope. So negative 3 and negative 3 are the same, so I have the same slope. Y-intercepts next. I have the same y-intercepts, and if I have the same slope and the same y-intercepts, I know I have infinite solutions. None of those work. Okay? Then when I look and say, what is the slope of this line picture? Well, slope is just your slope triangle created between 2 points. So I'm going to find 2 points that cross evenly. Right there it crosses evenly, and right there it crosses evenly. It also crosses evenly here and here. Okay? And now I'm just going to draw and see that I'm going plus 1, 1 to the right. I'm going plus 2 up, and it's always change in y over change in x. So my slope is going to be 2 over 1, which is 2. All these will go away. So now you're going to get some practice problems for page 3. Good luck with them. We'll get back after it in a second. Okay, so here it's asking what is the y-intercept of the line shown. Well, the y-intercept is where it crosses the y-axis. this is my y-axis, and that line crosses it right here, which is at point 1, 2, 3. So it'd be point 0, 3, or you can think of the y-intercept as just being the y-coordinate that it crosses the y-intercept at, which is 3. Okay, it says if the slope of the line is undefined, then it's vertical, and its equation would begin with x equals, which is true because if we have a line, my x is equal to like 1 here, well, x is equal to 1 everywhere on that line. So that's how I know something is undefined, when it just says x equals. So that answer would be true. Okay? Here it's saying the slope of the line pictured is 0. Well, we're looking at a horizon line, which is right there, which is a horizontal slope, which is a 0 slope according to our song. So it would be true. What is the system to the solution shown? Well, a solution to a systems of equation is the point where the two lines cross. And I can see the two lines cross right here, which is 1, 2, 3 over, 2 down. So it'd be 3, -2. That would be my answer, 3, -2. It says if a system of equation reveals that that it has infinite solutions, then the lines have the same slope and the same y-intercept. Well, if they have the same slope and the same y-intercept, they do have infinite solutions. So that is also true according to our notes. It says if a system of equations has different y-intercepts, there can only be one solution. Well, that's not true. The y-intercepts don't tell you how many solutions. It's predicated on your slope. So we have to say false for this one, because since we don't know our slopes, we can't predict how many solutions it has. And again, I'm going to give you some time to work through some sample problems from that part of the packet, and then we're going to get back after and do page 5 and then page 6. Okay, so it's asking for the equation of the line shown. Okay, to do that, you have to figure out what your y-intercept is and what the slope of the line is. So when I'm looking at this line, I see that my graph, even though I can't enlarge it like you guys get it on the computer, I can see that's crossing at +1. So I'm going to cross off any one that doesn't have a +1 after it. Then I can also see that my slope is going in a downward direction. If I cover up the left side and add an arrow, it's going downward, which means it has to be a negative slope. So this is the only answer that it could be. However, if I wanted to double check, I could see that I'm just going +1 over -1 down. So it'd be -1 over +1, which is also -1x. So it all works out. But I didn't have to do the math to solve that one if I just looked at my graph. So it says, what is the equation of a line that has a slope of 7 and a y-intercept of -3? Well, my slope-intercept format says y equals mx plus b, where 7 is my slope. So now I have y equals 7x plus, and -3 is going to be my y-intercept. So we'll change that to a -3. Then I'm going to find my equation that reads that, which would be right there. This is one of the tougher ones, solved using the substitution method. It was also one of the ones we went over in class with our notes. So remember, to solve a substitution, all you have to do is find one equation that says what y is equal to. In this case, this equation right here is telling me what y is equal to. So I'm going to take this and plug it in to my y value. So I'm going to have 2x minus 3 parentheses x minus 1 equals -1. Going to distribute my -3 into my parentheses. So now I have 2x minus 3x plus 3 equals -1. I'm going to combine my like terms here. So now I have -1x plus 3 equals -1. I'm going to move my 3 to this side, so I have my x's on one side and my numbers on the other. To do that, I take its opposite. That goes away. So now I have -x is equal to -4, -1x, and now I'm going to divide both sides by -1. That goes away. Negative divided by negative is a positive. So my x is equal to positive 4. Same thing for this case. I need to find the value, find one of the equations that has y equals to something. In this case, it says y here is equal to 6x minus 11. So I'm going to plug that into the y value down here. We're going to have negative 2x minus 3 parentheses 6x minus 11 equals negative 7. Bring in my negative 3 again. So now I have negative 2x minus 18x minus 30 or plus 33 equals negative 7. I'm going to combine my like terms. So now I have negative 20x plus 33 equals negative 7. Now I'm going to move my numbers to one side and keep my x's on the other. So to do that I need to move my 33 by taking its opposite. So now I have negative 20x is equal to negative 40. Now that I have that, I have to divide both sides by negative 20 to get x by itself. A negative divided by negative is a positive, and 40 divided by 20 is 2. So I have positive 2 as my solution. Okay, and again, you have some more practice problems coming up. Good luck, do your best with them. They will mirror every single problem you just did on this page. And last but not least, we had our one final question, which asks us to solve the following system using substitution. Again, we find where y is equal to something. Here it says it's equal to 4, so I'm just going to plug it directly in. So 3x plus 5 times 4 equals 20. 5 times 4 is 20, so now I have 3x plus 20 is equal to 20. I need to move my 20 so I get my x's on one side. So I'm going to minus 20 from both sides. That goes away. Now I have 3x is equal to 0, which means x is equal to 0. Okay? X is equal to 0 in that case. Y is going to be equal to 4, which means 0, 4 is my solution set. Alright. Good job, guys. Pretty sure we'll leave those two off. Good.